So this is a continuation of our notes. Make sure we're on the right slide. This is section 1.4 on angles. What we're going to look at in this video is finding the measure of angles. So in geometry, angles are measured in units called degrees. That's the degree symbol right there. So this is angle ABC or angle CBA. Either one's acceptable. Its measure, that's what that little lowercase m is. Measure of angle ABC equals 43. So notice how it tells you right here, this is read as the measure of angle ABC. So all this is doing is it's giving a size to the angle. How far apart or how far spread are these rays from each other? A degree is just a small little unit. So there's 43 degrees of spread between the rays. There's different types of angles, all of which you should be pretty familiar with. Right angles are angles that have a measure of 90 degrees. They look like a perfect corner. If you look around in the room that you're in, there's going to be more right angles than any other type of angle in that room. Acute angles are skinnier angles, so their measures are less than 90 degrees. You could fit an acute angle inside of a right angle. Yeah, I'll draw you an example of one. That's what an acute angle looks like. This is what a right angle looks like. Now, we don't know it's a right angle for sure unless there's this little box here. Okay, we'll talk about that more as we go though. But notice how this little angle would fit inside of this angle. It would fit like right in here. That's what makes it acute. Obtuse angles are fatter angles. They have a measure that's greater than 90. So if the measure is greater than this right angle, the angle is going to be open wide like this. That's what an obtuse angle looks like. Okay, now if you look around your room, you're going to see some acute angles and some obtuse angles, but probably not a ton. Straight angles you might not be familiar with. Those are angles with a measure of 180. Now it tells you here that it looks just like a line. So that was a pretty awful line, but that's what a straight angle would look like. If you remember back to what opposite rays are, same type of concept. That's what straight angles look like. So in this section, we're going to see some diagrams where there are some lines. You can consider those straight angles as well. So by appearance, let's classify these angles. This one is a bigger, fatter angle. That's obtuse. I'm not going to write it out. Your skinnier angle that would fit inside of a right angle, that's this one. That's acute. By appearance, this sure looks like a right angle. We don't know for sure, but it does look like it. And then this one is a straight angle. Postulate number 3 is the protractor postulate. What it does is it shows you how to use a protractor. Protractors measure angles. So it tells you how big or how small they are. It gives you that measure of degrees between the two rays. Here's an example. This orange semicircle would be like your protractor. I think you've all seen protractors before. Now these protractors have little degree units the whole way around the circumference of this semicircle. So there's a scale that goes from left to right. That would be the top numbers. Okay, so we have a scale going left to right. Notice how they increase. Look at the top numbers, 0, 70, 90, 155, 180. And there's a scale going to the right also. Depending on where your angle is, sometimes you need to measure left to right or right to left. Look at the scale going right to left. Bottom numbers, 0, 25, 90, 110, 180. they increase going right to left. What we're going to do is we're going to find the measures of all these angles that are listed. And we're going to do it. You could count the little degrees if you wanted to on your protractors, but notice how we don't have the little degrees marked on this one. So instead, what we're going to do is we're going to take the values that these rays go through on the protractor, and we're going to subtract them. Now, just like the ruler postulate, our angle measures are going to be positive in this course. So you're always taking the absolute value. Okay, so let's take a look at number 10. Measure of angle AFB. Always make sure you know where the angle is first. Here's angle AFB right here. What is its measure? Well, you can use both top numbers and subtract, or you could use both bottom numbers and subtract. It's totally up to you. Notice how the top numbers have a 0. That's always easier to subtract with a 0. So our two top numbers for that number 10 would be 70 and 0, because those are the rays that make angle AFB. Take those two numbers, 70 and 0, and subtract them. That's the measure of angle AFB. And that should make some sense to you, because that's a skinnier angle. That angle would fit inside of a right angle, so it's acute. Now, if you would have used the bottom numbers, 180 and 110, and you would have subtracted those, you would have still gotten the same number, 70. So it's up to you. Use both tops or both bottoms. Don't use one of each. Okay, I'll switch color and we'll do a different one. Actually, you can pause the video and do number 11. We'll do number 12 together. We want to find the measure. This is how you read this. Measure of angle BFE. Find it first. Here's angle BFE. It's this one. I think you can tell immediately it's a bigger, fatter angle. So that's obtuse. So we should be expecting a measure that's bigger than 90. So I'm going to subtract some numbers, one number from each ray. Now, if you want to use the tops, you can, but I'm going to use the bottoms in this one. I'm using the bottom numbers because notice I see an easy number to subtract with, 0. What is the measure of angle BFE? It's 110 minus 0. Okay, so that gives you 110, and that makes sense. It's an obtuse angle. It better be bigger than 90. What if you subtracted the top numbers? 180 minus 70. You still get 110. You can pause this video, do number 13. We'll do number 14 together. We want the measure of angle BFD. That's how you read that. Find angle BFD. Trace it with your finger or your pencil. We need to subtract one of these numbers from one of these numbers. I'm going to use the bottom numbers. So if I want the measure of angle BFD, I'm going to take 110, and I'm going to subtract from it 25. That's going to give me 85. That's the measure of this angle. It'll be 85. That's less than 90. So this angle is acute. That's how you use the protractor postulate. It's as simple as finding numbers that your rays go through and subtracting them. If you subtract in a certain order, you may get a negative number. Remember, angle measures are always positive, so you can just discard that negative, or you can take the absolute value of that difference.